Before we start with this course, I would like you to see a short video that we took by going out of the studio and asking random people on the street, both students and non-students alike, two very simple questions. The first question was, what is machine learning? And the second question was if they think linear regression is part of machine learning. Please watch the video and try to answer those questions for yourself. And then please memorize it, and then you can come back to these questions later and see whether your understanding of them will change after you take this course. Thank you.
Well, it's a part of artificial intelligence. Basically, it's a way that machines are learning. You know, you give them a ton of data, and from that data, they're able to gain knowledge, and then ultimately use artificial intelligence to come up with another idea or solution. So it's really feeding them data, and from that, the machine gets smarter, is able to, make decisions. So.
Machine learning helps, get insights, because I think there's a lot of disruption around technology, but there needs to be a disruption around mental models of people. So it's definitely like the next big thing. I mean, with AI and VR. And
learning is modeling computers to imitate the human brain and evolve to learn problems, to solve situations. One example, I guess, of machine learning would be Google's self-driving car. That was completely machine learning. In the beginning, it was completely dumb. It had no idea what to do. So what you do is you have the car just do some actions and then tell it if it's a good action or not. And then through positive feedback, we just keep on rearranging its parameters a little bit one by one until it satisfies your goal. And then from there, you just keep on making it more and more complex until you can, until it solves the task, which is what you want.
From an electrical engineering point of view, we have our students do analysis, mostly analysis. I give them the circuit, they kind of tell me what the circuit's doing. Right? But if I flip the problem to a design problem, I tell them, well, this is what I want on the output. The number of components or the degrees of freedom in there to get the circuit to perform takes some doing. They have to guess. They have to say, well, I got to guess at something. I don't have enough equations for all the unknowns, so I have to guess. And it's that gut feeling guess that usually you're wrong in the beginning, and then slowly over time you can start to develop where you should start. But it's that initial guess that gets a little tough. So for me, I think I can, with enough pumping in data what works, what doesn't work, I could get somehow some software to do a better job at the initial guess, actually do the complete job for me, without me creating these huge spreadsheets with every combination and then me looking for areas where, oh yeah, this is the area that sort of works. I could have something else do that for me. Interesting. So for the little bit I know about neural networks and how you have to train them, I guess it sounds similar. I'm not the mathematician to kind of give you that, but my gut is you're kind of fitting something expected to something that's kind of not right. I would look at it from the stock market point of view, right? So I have data. It's kind of random, the random walk theory. Obviously, I'm sure people are looking into this, but can I look at a data set and kind of say, oh, there's cycles here? I mean, it's right. From a point of view of people that invest in the stock market, right? There's two. There's the chartists, and then there's the fundamentalists. I probably have the names wrong. So one person looks at the balance sheet, says, oh, this is the stock you need to buy. The other person says, I don't need to know any of that. Just plot the charts, put some trend lines and things, and we could figure out the direction it's going. Or broke the trend line, I can know. You could probably dump that into some algorithm, and it's kind of like a linear regression. I'm looking for trends, I'm looking for cycles, I'm trying to predict what's going to happen next. So I would say if I had to guess, is it close? I'd say it's probably in the ballpark. If I'm wrong, just end the video.
No, it isn't. Because for linear regression, there's a set formula to calculate the line of best fit to go through points. And what machine learning does instead is that it tries to evolve, let's say, a curve that best imitates those points. So linear regression was like a set formula. There's a set formula in some textbook somewhere that says, oh, here's how you calculate the line of best fit. Well, if I were to tell a computer to define me the line of best fit through machine learning, it would try and calculate it, and there would be lots of different things going into that. Like, you know, it shouldn't be too accurate. It should represent the general situation.
Yes and no. There are so many like similarities to it, but it's, I mean, there's no one silver bullet, right? So
Right.
it's like half and half.